Hi, how are you? Today I will be recording a question from a past year paper and I'll be continuing this series further. Every day I'm gonna post a question from a past year paper and you are open to send me your queries and you can DM me for your personal session. So let's just quickly get started. So for the function given to us is y is equal to x to the power of 4 minus 4x cube plus 1. So we need to do this question without the assistance of calculator. So it's a calc-free question. Then comes a coordinates of x-intercept. So okay, let's just do this. So coordinates of x-intercept. So where it cuts the coordinates of y-intercept. So where it cuts the y-axis. So put x is equal to 0. If x is 0, so what you're gonna get? Y is equal to 0 to the power of 4 minus 4 times 0 cube plus 1. So it's just y is equal to 1. So y is equal to 1 is the y-intercepts. Now behavior at as x tends towards positive infinity and negative infinity. For this, as x tends to positive infinity, think that I'm going to sub in a really huge positive number. So a huge positive number is there and its behavior gonna be determined by the highest, usually it's by this only. The highest power of x determines or sets the tone of the function. If you set in a huge positive number, x to the power of 4 will gonna be a huge positive number, and here I'm plugging in a huge positive number. So here I'm gonna get y gonna tends towards huge positive number. If x tends towards negative infinity means, okay, let's see, if x is equal to negative 10, y is equal to what? Negative 10 to the power of 4. So it's 10 to the power of 4, positive 4, 10 to the power of 3 plus 1. Right, a positive number, it's greater than 0. If x is equal to negative, you can take 1000. So again, 1000 to the power of 4 plus 4, 1000 to the power of 3 plus 1. It's greater than 0. So on you keep in negative, start subbing in the negative number. You're gonna see that your answer gonna be a huge positive number, and its tone gonna be determined by x to the power of 4, because no matter what your x cube is, x to the power of 4 will go faster as compared to x cube. This cube tends y tends towards positive infinity. Okay, then comes find the location and the nature of the turning points. So since this is a year 12 question, so now you are aware of second derivative, right? So we guys gonna find critical point or the turning point with the help of first derivative and use second derivative to determine its nature. So c is equal to, so what is my dy by dx? 4x cube minus 12x square, that becomes 4x square x minus 3. Right, now you put your dy by dx as 0. So dy by dx is 0, product of these numbers is 0. It means either x square is 0 or x minus 3 is equal to 0. If your x square is 0, this gives us x is equal to 0, or if x minus 3 is equal to 0, that gives you as x is equal to 3 is equal to 0. Right, so we have determined the location. Now these are the turning points for sure, but to determine its nature, let's go towards the second derivative. So I'm going to do it over d square y by dx square. So I'm going to differentiate this further. So it's going to be 12x square minus 24x. Right, now plug in, now at or you can say at at x is equal to 0, your d square y by dx square is equal to 0, no? So we need to investigate it further. Now you have at x is equal to 3. If x is equal to 3, what will happen to this one? So 3, 9, that's 108 minus 24 times 3. So what is 24 times 3? 3 4s are 12, 1 taken out. It's, oh yeah, it's going to be a positive number. So x is equal to 3 is the point of minimum, right? So we got one, we have sorted for the x is equal to 3 is the point of minimum, but still what is left, x is equal to 0, so we can't determine it from the second derivative, so we need to do the sign test from first derivative. So let's just quickly do that. I'm doing out here. So it's a 0, 3. If you take any point less than 0, let's take -1. If you plug in -1, it's gonna be a negative number. If you plug in a +1, it's gonna be a negative number. If you take any number greater than 3, it's gonna be a positive. So you can see that the sign of the first derivative is same on both the sides, and hence x is equal to 0 is a point of inflection. So x is equal to 0 is like x coordinate, not the point, x coordinate. But what does the question ask us to do? Find the location in each of the turning points. So x is equal to 0, so we need to do this. I'm gonna take it on a fresh sheet. 26, 3, and this is your 26, and it's 108, so it's 26, so it's gonna be -26. So we got the 0, 1 is the point of inflection, and 3, -26 is the point of, what we can say, point of minimum. This is the point of minimum. Now comes your second derivative. So what is your second derivative? It came out as 12x square minus 24x, right? So this gives us d square y by dx square is 12x square minus 24x. So this leads us to, if we pulled out 12x, it's x minus 2. So d square y by dx square is 0, at which point when x is 0 or x is equal to 2. Let's make the number line. So here it's your 0, here it's your 2. If you take any number less than 0, -1, so this is negative, this is negative, it is positive. If you take any number, let's say positive 1, 1, 1, it's negative. If you take anything greater than 2, so let's take 3, so it's positive. So when it's positive, so it's a concave up, this is a concave down, this is a concave up, right? Now here comes the twist. When you are sketching it up, then we need to be very cautious as in we need to coordinate with the second derivative and the first derivative. What I wanted to say, let's sketch it out, then you will have a better understanding.